Please confirm. Great. Vidya, am I audible?
Yes, you are.
Perfect. So let me straight away start sharing my screen and okay. I hope you can see my screen with the presentation slide.
Yes, but it's not in full mode yet. Yes, perfect.
Okay, great. Hello all. Hope you're all doing great. I really appreciate for taking your time to attend this session that on a weekdays on Monday evening. But we will ensure that you will really find that very interesting and also have some takeaways after this session. And the main aim of this session is to make sure that the students or the professors who is attending the session is understanding the basic concepts of AI agents and also the fundamentals of AI, ML, and LLM jargons that focuses on building a robust AI agent. So that's where we are going to take you all through today. And with that note, I will go for a quick introduction. Already Vidya gave a very great introduction about this. And to just make it short, I'm Palani, a technical architect from Novo Nordisk. And you can feel free to reach out through UiPath Forum or a LinkedIn. And I'm always open for any discussions around this. And this is a QR code. You can scan it and follow my page for any articles or blogs or posts and discussions in LinkedIn. I'll pause for maybe 30 seconds and then post that I will continue. All right. I'll also post this link in the chat so that you can get it enrolled. Okay. Great. So this is the agenda for today's session where I'll be taking you all through a roadmap that will tell us on how to become an AI agent and what is needed to become an AI agent expert. And followed by that, we'll also have a quick introduction about agents. And next will be the fundamentals of AI MLs, focusing on building an AI agents. And then if time permits, we'll also have a Q&A and let's close up our session with that. So with that note, let's look at the roadmap. So right from 2024, everyone started looking at agent as something very niche and maybe a technology that is far from a common person. But it's not that case. But if you just look at it a little deeper to it, it's pretty simple and it's the same thing, maybe a little evolved one from the existing AI landscape. And if someone is aspiring to become an AI agent expert, then it is really important to brush up few of the fundamentals before we get into that area. And this is what I have tried to draft in a very simple way for anyone who is aspiring to become an agentic AI expert. And to start with, it's the fundamental of AI, ML, and LLM, where someone who's starting with the fundamental has to cover these below topics, especially the LLM architecture and how a basic LLM model works. What are the different types of LLM models? And what are the subtopics like tokenizations, embeddings, deep research? And out of all that, someone must really understand which LLM is really good for what and when they can use that LLM. And that is something very important to understand. And followed by that, a person has to really go through the agentic architecture, have a clear understanding of how each component within that architecture is integrating with each other and then making that as an agent. And for that, we need to understand its architecture and then also the types of agents so that you will know which agent will be suitable for which use case and all those stuffs. And uh, and also we need to understand what is context management and what are vector DBs and what is semantic search and semantic match, all those topics under agentic architecture. And as a third step, it is very important again, like maybe it sounds very simple, that is a prompt engineering, but that is a very basic thing for any agent that uses LLM model. So we need to understand how to create a prompt to create an agent, because there are many types of prompts which are there, and someone who's trying to prepare or create an agent has or must have a clear understanding of what is prompt engineering is about. So we'll be looking at multi-step reasoning, what is a RAG, and how it differs from fine-tuning and prompt engineering. And we also will look at some of the basics topic like zero shot, few shot, one shot learning, and all the stuffs under this prompt engineering and task adaptation topic. And the final one, where once you have gone through all of these fundamentals, you will be landing up in a position to create agents. But while creating, you must be in a clear picture of what are the agentic frameworks which are available to be leveraged, and what are multi-agent frameworks? What is an AI agent and how it differs from agentic workflow? Because these two terms are different under agentic AI systems. And you also need to understand what is a multi-model agent and what is multi-modal agent. Because these two terms sound similar, but they are completely different from each other. So we'll be having sessions under these specific stages of this roadmap. But for today, we'll be focusing more on fundamentals of AI, ML, and LLM, and a quick introduction of agents to have to maybe like gear up for the next sessions, that is agentic architecture. So we'll be focusing on the first part of this roadmap, and I'm pretty excited that the sessions or the topics that we have for today will be at your interest. So before we move ahead further, I would like to encourage everyone to have the next session also enrolled, because after this session, we have a follow-up session on April 24th on agent architecture, types of agents, and memory management and rack. So this is the QR code. You can use your camera, scan it, and then enroll it. We also will have all these QR codes or the links posted in the chat so that you can refer them at any point during the session. I will pause for maybe next 15, 30 seconds, and you can scan this QR and then can enroll yourself. Great. I'll move for the next slide. All right. Everyone on seeing this slide would be thinking that, hey, I have seen this somewhere. Yes. And I want to start something that is very familiar to everyone here in this session. And this chart is something that you would have seen across all the social medias when someone is searching for AI and its branches. And you can see this branch looks more comprehensive, and that's the main reason why I like this picture. And it covers the branches of artificial intelligence and what are the major components within each of those branches. And now for this session, we will not be going through all of this because this will take years to understand each and every topics. But we'll be focusing on what is AI, what is generative AI, what is large language model, and what is agents on a high level, right? Okay, with that note, let's try to understand or maybe start with the difference of agentic AI and generative AI. Everyone here in this group or the session would have used ChatGPT, right? Or maybe DeepSeek, which was recently launched, or Grok, or any other LLM models. And those LLM models come under generative AI because generative AI, as the name implies, it is an AI system that is capable of generating any text or any content. When I say content, it is inclusive of text, image, voice, audio, or it could be anything. So that is why it is so called as generative content system. So you can use this GenAI to process any documents or a text or a audio or video, analyze it, summarize it, make some reasoning around it, and then process that and pass it down to the next set of stream in your process. That is where generative AI comes in the picture. And when you see this, you would have observed that LLM models or ChatGPT, even to take an example, doesn't have a capability to make a decision by itself. It really waits for someone to add a prompt or an input from a user. Let's say if you're using ChatGPT, you have to type your input, and only then this will process that and prepares a generative content out of it. So it relies on someone's input, so which means it doesn't make decision by itself. So these are some of the major characteristics of generative AI. But if you look at the other side, which is completely contrast, that is agentic AI, is something that is maybe if I have to put it in a one single line, any AI system, if it is capable of making decision by itself without human need, then it is called as agentic AI system. And that's why it is called as autonomous. When I say autonomous, it doesn't rely on any input or any human intervention across at any point in the process. And that is why it's called as autonomous. And in order to be autonomous, it has to be driven only on a goal-oriented basis. It has to have a goal at the end and it has to be driven on the same line. And when it is being driven on the same line, it might be relying on some external resources. It could be a tool, or it could be even another LLM model, or it could be a database, or it could be anything. So that's why it uses tools and APIs. And when an LLM model is given with all these components, it becomes independent and it can make decision by itself. So that's why it is called as agentic AI and an autonomous AI system. So now I hope it's clear how it differs between agentic AI and generative AI. And because generative AI is something that everyone is aware about and we are using for last 2, 3 years. And agentic AI is something that very new, and it is very important to understand how it differs from something existing in the world. Okay. So let's see some of the major components within agentic AI so that you will understand a little bit more about what is agentic AI and how it is going to really help us. Okay. So if you have observed something that the previous slide, I was trying to point out or highlight a common term that is LLM, is large language model. And you will be using this large language model in a very great extent with any agents that you're going to do in future. Because that LLM is what is going to process your text or the content that you're passing to that agent. And based on that, it will be able to read through it and give you something out of it. But let's try to understand what an LLM can basically do on a simple note. Let's take again an example as ChatGPT, where you'll be typing something as a text or an image as an input to that chat interface, and it will try to read through it, process it, and then it will give you again as a text or an image, right? So this is a basic LLM flow. That's what it is being portrayed in the slide as well. And if I try to add a little bit more or an extra set of components to it, that's where agent gets built. Let's look at what it is. So here, if you see, I'm adding my text as an input to an LLM model, but I don't stop there. I'm also adding some documents, images, or videos as a knowledge base. And followed by that, I'm also adding some memory to it. Because when you are typing in a chat GPT, once that session gets closed, or if I have to refer any LLM models, once that session is getting closed, it will not be able to recall what was discussed in the previous session, which means it doesn't have a long-term memory within that. So we have to really have a memory in order to make that agent to understand the previous conversation or the previous content and make a decision out of it. And followed by that, if an LLM model is added with a reasoning ability, when I say reasoning ability, it's something like I'm giving a text to an LLM model and I'm asking it to refine that. So let's say I'm drafting an email to someone and I'm using an LLM model to refine that email content. After refining it will give me that content, but that may not be the final one that I'll be utilizing for sending as an email, right? I would have expected that LLM model to refine that again and again and again until it is really, really a perfect format. So LLM doesn't do that unless and until I tell it to do it. So on that note, if I'm adding a reasoning and an iterative session within that, saying, hey, I've given you the input. I want you to refine that again and again until you find that as an optimal one. And if that capability is given to an agent with this LLM model, it will be able to make a perfect decision of what is being asked of it. And along with that, once the input is given, once the knowledge base is given, once a memory and a reasoning ability is given, if I'm also given an access to tools and platforms through APIs or through connections, then it will be able to perform that decision not just as a text outcome, but also as an action. And that is what an agent basically do. So it doesn't end by just giving a text. It also gives an action. So if an LLM model is added with these components, giving us an action or a text brought out of considering all the decision-making points, then that is what is called as agentic AI, right? So now I believe you will be clear about what is the agentic AI and how it will leverage LLM models with external components to act as an agent, right? But still, I find and I strongly believe that many would have gone through different terms of agentic AI. And even when I was explaining you with the session so far, I would have told that AI agents, agentic AI system. So which one is the actual terminology that has to be used? So let's look at that. So agentic AI is the broader concept. So if someone is talking about an agent or someone is saying that I'm going to build an agent, it falls under this agentic AI terminology, right? And this agentic AI still comes under artificial intelligence as a branch. And as I told you, any AI system, if it is able to make a decision by itself, then it is called as agentic AI. And this agentic AI sounds more of a broader concept, right? And under that broader concept, it encompasses two major categories. That is AI agents and agentic workflow. Clear? So under agentic AI as a concept, there are two different categories, that is, or sub branches, that is so-called AI agents and agentic workflow. So if I have to explain starting with AI agents are something that is designed for a specific platform or a specific module or a specific set of tasks. Let's say an example, Siri or Alexa, or even with UiPath, if you see, Autopilot, or if you have to look at the other components, Copilot, or any AI assistant built for a specific platform to handle specific set of tasks, then it is called as AI agent, which means it is a standalone component built for a specific platform. Clear? And when you take a business process, once you get into a company, it doesn't end up with just handling one specific tool or a component, right? You might be using the tool or you might be using that software along with additional set of softwares to cover up an entire process. So if you take a process, it will be having n number of steps, like 1 to 10 steps, right? And in that 10 steps, you will be using some softwares for each of those operations. One for CRM, one for ERP, one for interface, like that. So for each of these softwares, you would have built an AI agent, right? As I told you, AI agent is a standalone component or an AI system built for a specific software or a platform. So you would have built n number of AI agents for each of these softwares. And if you club all of those along with the rest of the steps involved in a process, then it is called as agentic workflow, which means a workflow will be involved with n number of steps, where some of those steps will be handled by specialized AI agents. And when those gets combined together, that is what is called as agentic workflow. So if someone is talking to you that, hey, I'm going to build an agent with UiPath for a CRM tool, then it is called as AI agent. And when someone is saying, hey, I'm going to build an agent for a procure to pay process in finance, or I'm going to build an AI agent for HR recruitment process, then it is called as agentic workflow. So you really need to understand how we are going to use this agentic AI system and how we are going to build it. So which means these two categories depends on what kind of problem you're going to solve. When you're going to solve a problem within one specific platform with an AI agent system, then it is called AI agent. And if you're trying to solve a business process altogether, then it is so-called agentic workflow, right? I think now it is very clear about what are the major terminologies that someone has to really uh, consider when someone is explaining about agent. But let's have a quick example of what is this AI agent and how it differs from agentic workflow. So the one that we saw in the very initial stage during this session, that example is a very good fit for AI agent. So I would have built an architecture on a funny note, something like this, to create a customer support AI assistant, or maybe you can take your Siri as an example, or Alexa as an example, or Autopilot as an example. So that is what is called as AI agent. But if I have this AI agent built with specific software, and if similar agent, or maybe if I'm building multiple agents tagged to a process involving many steps, then it is called as agentic workflow. So here you can see I have built an agent for monitoring a machine performance, another agent to predict a maintenance need in a manufacturing unit. So that I built a smart manufacturing system where a robot, and an RPA bot will be involved in extracting the data from a machine backend system, pass it to agent one, analyze the performance, and then pass it to agent two, predict that, and then adjust the production schedules. And once that is done, again, it sends the outbound data to another bot that will update the backend details accordingly. So here, if you see agent is involved, RPA is involved, and there are a few other steps are also involved, right? So it is more of a business process, and that is why it is called as agentic workflow, right? It's a workflow altogether. So that's why it's called agentic workflow. So now I believe how agentic AI is termed out and what are the categories under agentic AI, which is AI agents and agent workflow. So I want to bring this comparison on a very important note that uh, down the line, if you see before maybe 5 years or 6 years, RPA was booming like anything. And especially during COVID time, automation played a major role in all the industries. And everyone started bringing their digitization model and automation in place. So now if you see RPA has evolved over a period of time, and now we are at the place where agentic AI is going to get added to that RPA features. But it is important to understand how it differs from automation. So if we just have a quick glance glance at this comparison, you will understand. Uh, okay, sorry. Yeah. So you will understand how it differs from automation, how it differs with agentic workflow, and how it differs with AI agents. So the last two columns is something that we discussed a few minutes before, and I want to correlate with how it differs with automation. So these are the core foundations, tasks, and strengths and weakness. Some of the major definitions that I would like to make use of for the comparisons. So, and I want to really look at the task as a major one because automation is more of a rule-based, deterministic, and predefined task, whereas the agentic workflow, it's still deterministic, but more of on a flexible side. But if you see AI agents, they are completely deterministic. So when I say deterministic, it doesn't run on any um, predefined set of rules or predefined set of tasks. So a process can come up with any task. A process can come up with a predefined set of tasks. And when a process is with a predefined set of tasks, and if you want to handle that with an agent, you go with agentic workflow. And if it really needs some human in the loop or any sort of human intervention, then you go for automation. And if you're building an agent for a specific platform within that process, then you go for agents, that is AI agents. So that's how you pick these technologies based on the task that you come across. And maybe if I have to go with the last one, that is example, that if I have to take under automation, you can see send a Slack notification every time a new lead signs up on our website. So it's more like event-based triggers. Like someone is signing up on a website, it sends a Slack notification. So that's very simple. It doesn't need any AI component or anything that is beyond human intelligence, right? And maybe if I have to take an example for agentic workflow, that is like analyze, score, and route every website inbound lead using ChatGPT. Like if someone is trying to use a website and then if someone has to validate how it is being utilized, then it has to be go through different components within the website, right? Back end, front end, database, and all those stuffs. And even the memory and so many other components, right? And it can also be linked to few other external components or external websites. And so it has to be managed with some intelligence beyond a human can think through it. And there you need an AI system, and that's where you will be using agentic workflow. And if you're looking for a specific task or a tool to be built with an AI system, then you can bring in agent AI agents there. And if I have to quote an example, you can ask that agent to look for a specific set of information through a web search and give the best approach out of it. A simple one could be booking your flight tickets or making a reservation for a hotel or a restaurant, something like that. So these are the comparison that you really need to understand. And I want to highlight something or maybe um, uh, to emphasize how UiPath has sailed through this evolution. And this is what UiPath has got as a journey from an RPA to an agentic automation. So far we have seen how this agentic AI can be used either as an AI agents or an agentic workflow, right? So we will be looking at how UiPath has uh, grounded that technology and then made use of those and then came up with their own style in terms of agentic automation. So if you see that 2018, we started with UI-based automation and then API-based automation. And then we brought up IDP, that is intelligent document processing, that helped to handle structured data. And then over a period of time, there are many things open to handle unstructured data. And then UiPath also came up with Gen AI activities down in 2024, where ChatGPT and many open AI and or similar LLM models were introduced in the market. And now we are into the agentic process era, and UiPath is coming up with this tool named Agent Builder and Mastro, and they are going to get launched with this April 30th. So if anyone is coming to UiPath DevCon at the end of this month in Bangalore, you'll be witnessing that launch. And from there on, it will be more of a public use so that anyone can explore how agentic automation is possible with UiPath. So, yeah. So now we have gone to the next part of this session. And I strongly believe that you have a fair understanding of what is agentic AI, the top level of AI system, and under agentic AI, what is AI agent and what it does, and what is agentic workflow and what it does, and what are the capabilities. So now let's look at the fundamentals of AI, ML, and LLM models that is being used or being used under the hood of these AI systems. And we'll be focusing only on the agent aspect, not on all the branches of this AI and ML because it will take a lot of time. So we'll be focusing on the major fundamental concepts that is used when you are building an AI agent, right? I'll start with large language models. And I would encourage every students or professors who are taking part of the session, feel free to take a screenshot or an image or a photo. And we will also have this recording captured in our event page, and you can pass it down to your peers. So if I start with large language models, um, when you are building an agent, LLM model is the most important component within an AI agent system. So that LLM model basically acts as a brain to perform all the reasoning and decision making steps because that's how an agent will make a difference from a normal automation, right? An automation is something that is rule based and it is more of a very defined set of steps, right? And doesn't need any human intervention. But if any decision making point is coming across in an automation, and if you're using an agent to solve that, then you will definitely need an LLM model involved within that agent architecture. So that LLM model will act as a brain. So let's see how it has evolved from a normal LLM to an agentic LLM. So if you see the left side of the screen with the image that has been drawn here, you you basically send a prompt and then the LLM receives that prompt and gives you an answer. And as a next stage, if you are trying to uh, ask, let's take an example on that. You're asking, hey, which one is the best spot in India to visit during the summer vacation? And it'll try to list down all the places, right? And now that is the first part of this diagram, the left side of this diagram. Let's move to the second component where RAG is introduced. And now we are asking the same LLM model that can you check my calendar when I'm available to take a vacation for this spot? And that LLM model will try to either hallucinate or it will tell you directly upfront saying that I don't have access to your database or your schedule. Only then I will be, only when I have an access to that, I will be able to tell you when you are free to be a part of this vacation. And that's where you'll be bringing RAG system, that is retrieval augmented generation. And we'll be looking at this more in detail in the next session, but that is the next evolution of LLM, and it is something I really want to highlight here. And along with this RAG, if you are adding some more external components like tools or an ability to reason, then it becomes an agent. So that's why LLM model is a key component in any agentic AI system. So I hope you understand the importance of having an LLM model and what is the major role that it plays in an agentic AI system. But when you're using an LLM model, it is really important to know which LLM model is good for what, so that based on your task complexity, you can choose that LLM models. So this might be like um, a little comprehensive, but maybe as a student, if you are more interested to know, I want to know which LLM model is really good at coding, then you can go for O3 Mini High. And if someone is looking for a long context handling, then you can go for Gemini. And if you're someone looking for image generation, then you can go for Claude. Even Gemini is also doing great, but to an extent, Claude is really doing better. And if you're someone who is looking for a content generation, straight away go for GPT-4o. Okay. So this is how you use LLM models, and you need to understand which model has to be picked. Because when you are building an agent, you have to be really open enough to consider one model or more than one LLM models, right? So on that note, you need to know which LLM model has to be used at which point and for which purpose. So it's really important to know that. Okay, so here I have a quick glance of a recommended LLM models. For coding, it's O3 Mini. For any write a content generation, it is GPT 4.5. And the general AI use, it's GPT-4o. And then multi-modal task, you can use Gemini 2.0. So you will be wondering, what is this multi-model and multi-modal? So the one that you see in this slide is multi-modal task, which means an LLM model, it is not just prone to accept text as an input. It can also accept a video. It can also accept an image. It can also accept um, a screenshot or a document or it could be anything. So that different sort of input is so called as multi-modal. And when I say multi-modal, you can see the difference in the accent. So multi-modal is something that you are using different LLM models for a process. You can use GPT, ChatGPT, you can use Gemini, you can use DeepSeek for their respective complexity. So here I'm using multi-models, right? LLM models. That is what is called as multi-models. So you need to understand the difference between multimodal and multi-model, right? Okay, so I want to take you through a little bit more inside the LLM models and its architecture, because when you're building an agent, you need to go through certain components within or certain components within large language models, or you might be ending up in a position to configure those components within this LLM models. So it is important to understand when you're configuring that components or the layers of that LLM model, how it is going to impact your agent. So it is really important to understand those nuances. So I am pretty sure that this architecture might be overwhelming to understand, but I want to take you to a very easy example followed by this. And this is something you can take it as a reference after getting through that example. Here you go. A simple example for LLM. So let's take again a well-known LLM model, that is GPT, ChatGPT. I'm trying to type something like London is the capital of, and I'm ending this statement there. And once I make that statement and click enter in any LLM models, that statement, which consists of n number of words, will get chunked to individual words, and that is what is called as tokenizations. And maybe I will, instead of me literally saying that, I will also make an opportunity to take to this slide where it is more self-explanatory so that you can read through this when I'm explaining through the steps. So, so where did I end? Okay, tokenization. So when you say when once the statement is made to the LLM model, it tries to break that input text into tokens. It could be a word, or it could be a punctuation, or it could be a set of words together, and it'll try to tokenize that. And that is what is called as tokenization. And once a tokenization is done, it will be tagged to an ID, like a series of numbers to that tokens. And once you have the tokenization done with an ID tagged to it, you convert that ID or place that ID in a large five-dimensional space that is so-called vector space. And you try to keep those tokens closer by, which are having a closer proximity with each other. When I say proximity, um, if you see London is the capital of, you can see London and capital or referring to some intent, right? You're trying to find a country or a place in and around London as a capital, correct? So these two words are somewhere you can relate to it each other, and then based on that relation, you can come up with the of a missing out word. And that is what is so called as proximity. When they are related to each other, they are of close proximity. And such words will be combined together or placed together in the vector DB based on their proximity levels. And once that vectorization is done, followed by embedding, then you will be introducing a transformer block. And this transformer block is something, a major component within any LLM models, like especially the GPT models. Because if you see LLM, I won't say like any LLM models, especially it's concerned to GPT models, because LLM models can be of different model. It could be a pre-trained model, it could be a fine-tuned model, it could be a transformer-based model, it could be like um, a different model altogether. There are a number of types within LLM models. And if you see transformer-based model, which is known by everyone, that is GPT, right? Generative pre-trained transformers, which basically works on this transformer architecture. And this transformer has got some multiple layers or layers like attention, self-attention, and feedback layers. And there are these layers will get layered one on the other like for a million times. And this transformer block will process those vector embedding vectors, and then it will try to find the next set of words. Let's say London is the capital of, maybe if I'm trying to hallucinate and say London is the capital of India, and it doesn't make sense, right? So this transformer will try to find that last word, and it has, as a first attempt, it has identified as India. And if it doesn't make sense, then it goes back again in an iteration to the same transformer block that, and it will try to find the final word again. London is the capital of, again, somewhere like Paris, and it doesn't make sense. Again, it goes for a reiteration again and again and again. And once it has found a final spot that's the best match, then it will try to convert that statement again as an output tokens. And that comes to the output layer, and passing that output layer again, it gets tokenized, and then it gets decoded and it gives you the outcome like London is the capital of England. So this is how a basic LLM model will work, and this is the basic architecture. So now if you go back to the previous slide when you're refurbishing again, then you'll understand how it is and how it works. But I want to pick few of the components here which will play a major role in building an AI agent. For example, embedding, tokenizations, and all those stuffs. Let's look at what are those major components. First thing, tokens. So when you are building an agent, you will be relying on LLM model to process any text or a video or anything, right? So when you are using an LLM model, you must be having a clear understanding of how the tokens or how the tokenization is made. When I say tokens, when you are giving an input text, or if a software is giving an input text to an LLM model, it is so called as input token, and it can have n number of words. Let's say you have a paragraph of 1,000 words, then it is so called as 1,000 tokens. And when this 1,000 token gets processed and you receive some refined output out of it, right? And again, that refined output might have 700 characters or 700 words out of it. And you will be ending up with 700 tokens, right? So you have 1,000 tokens and 700 tokens. When you combine together, it's 1,700, right? And this 1,700 is something that you really need to make sure your LLM model is bought with a maximum LLM token beyond this 1,700, or it should be more than 1,700. Let's say you are buying an LLM model with a maximum capacity of 5,000 tokens per response, then it is fine because now we have only 1,700, right? But if you buy an LLM model with a minimum tokenization token level, which is like a max of 1,000 token, then your agent won't run, saying that there's a possibility of getting an exception in the middle of execution saying that LLM model is not able to process your token as it has exceeded the limit. So you really need to know about how a tokenization is happening and how a tokenization is involved within a specific LLM model, right? And let's go for the next one, temperature. So when, let's say you are passing an input to an LLM model, and then you are also configuring a step saying that, hey, LLM model, you should consider my text and then make sure you're not hallucinating and make sure you're not giving some random output. It has to be very, very deterministic and realistic. And in that case, you have an option to configure through a term called temperature. And if the temperature is less than one, between like 0 to 1 or less than one, then it will try to give you a very deterministic and a very realistic output. But it may not be very creative. But if you are letting that LLM model to be with the temperature more than one or between 1 to 2, because 2 is the maximum threshold, then you are letting that LLM model to be more creative and it can give you any random output along with the along with certain level of context to your question. So you need to understand based on your scenario what type of temperature has to be set. It has to be less than one or more than one. So if it's less than one, it is like more realistic and more precise. If it's more than one, then it's more of creative. So you can keep your range between 0 to 1 based on those based on the precise content that you need, and based on the creativity level that you see for a period of time, you can modify between 1 to 2, like 1.2 or 1.5, 1.7. So that's how the temperature is helpful here. So these are the common jargons that you will go through in an AI ML concepts, but this is something very bound in terms of building an AI agent system. Let's look at context grounding. And this is again a very, very important concept when someone is trying to build an AI agent. So now I have given input and now I have told that you have to be very precise. I don't want you to be giving me a random content. I don't want you to be creative. I only want you to be very precise to what I'm asking. So I have set the temperature as zero point 0.3, 0.3, something like that. And now when I'm asking that LLM model to be as a reasoning or a brain for my agent, it will definitely look for some external resources to act as a precise model, right? And if you are not letting that component tagged to this architecture along with an LLM model, then it starts hallucinating, which means it will try to bring some random content and it may not be relevant to what you're even asking about, correct? So in order to constrain and make it very precise, you bring something like context grounding into picture. And if you see in UiPath, we have a UiPath managed vector DBs where you'll be having this context grounding performed, right? Let's take a quick example by reading through this slide. So you can look at the bottom of the slide where your user is querying or an application is giving a data input to an LLM as a prompt. And once the LLM receives that information, either from a user as a text or from a software or from an application, then it will try to connect with the context because it doesn't end up with just reading through the prompt and provide an outcome or a response. So what it does, so along with this LLM model, I have also tagged an additional layer in the architecture where I have added some knowledge base. It could be PDF or text or image or video, which is more relevant to what a user is going to ask or more relevant to the portfolio of an application as a knowledge base. So once that knowledge base is added, that knowledge base, it could be a document or a video or an image, gets chunked into individual components or a smaller components, so-called chunks. And that chunks is made with the help of an ingestion model and an embedding model. So if you remember what we saw in an LLM architecture, there were inputs, tokenizations, embeddings, transformer blocks, and outputs, right? Here you can refer to the same here. So once you give a knowledge base, it starts embedding. It converts that document into smaller documents, and individual smaller documents will be converted into tokens like individual words, and individual words will be tagged to a vector DB. And here you can see a term called indexing. So indexing is basically like once a token is created through an embedding model, it will be placed in a folder in a vector DB where that folder will be having words or vectors which are of close proximity. So that folder, that type of mapping is so called as indexing. So altogether, you call this embedding plus indexing as vectorization. And that is what is context grounding. And now let's get back to our process. The user or a software has given a text input to an LLM model, and that LLM model, along with the user input, it goes to this context grounding architecture, try to relate with the existing knowledge along with the user question and see how we can prepare a best response out of it instead of just creating a random response. And once that response is created out of this context grounding, you will be it will be passed again to the LLM model and it gets refined again and given as a response. And so here, if you see, the context grounding enables that LLM model to give a very precise answer based on um, some knowledge or details around that prompt or a text given as an input to an LLM model. So this context grounding is a terminology used within UiPath, and that is what is also called as RAG. So you will be using this context grounding when you are building an AI agent, uh, and you will soon understand the importance of having this context grounding. And wait for April 30th, you will also get to see how AI agent and agent builder uses this context grounding as a backbone. And after all these major concepts, I wanted to highlight um, something that was presented during UiPath Forward. And I really like this analogy that uh, that how a person has to approach an automation when they're approaching for agentic automation. So the future is more of an automation which is robotic and agentic, where a left or a brain of a robot, if you see, or a bot, the left side or a left region of the bot will be more of a structured and logical oriented, whereas the other side of the same um component will be more of creative and intuitive, and that's where agent comes in the picture. So that becomes more adaptive, and you can handle any complex process that was not possible to be handled by a normal automation. So automation sometimes can be very limited to handle when it comes to a complex process, right? So now with this agent, you will be easily able to handle that complex because a complex process wherever a human decision is needed can be taken over by this agents in place. And that's where UiPath is coming up with its agentic tools. So this is the agentic timeline where you will be seeing this general availability by April, that is from April 30th, and that gets launched during the DevCon. And if someone is coming to Bangalore to be a participant of this DevCon, you will get to see how this agentic AI and AI builders or Mastro is going to bring up a big revolution in handling a complex automation. And with that, I would like to thank everyone for uh, staying with the session, and I would like to hand it over to Vidya and Anju for the rest of the session. Thank you.
I hope you all had a wonderful session. Palani, I really enjoyed your session. Thank you so much for it. Um, and also, everyone, the recording of this video will be posted with the event link on the event link itself. Probably it will be uploaded in next 2 days. Give us that much time. And also, there are two other upskill sessions with Palani. Those are coming up. And please go ahead and register. I'll go ahead and paste the link in the chat box. Yeah. You can use this link and register for next two session, which is the continuity. Okay. Before I move on, I would like to share my screen. You guys are able to see my screen? Um, this is on UiPath Agent Hack India. Okay, before we wrap up this session, I hope this session enabled you with the many ideas that you can submit for the national level hackathon. The national level hackathon is where you can solve the real world problems with automation and get recognized at the national level. I have showed this is the link, submit your hackathon idea. This is the link where you can submit your ideas. Please go ahead and submit your ideas here. Next, if you want to know more about the UiPath community, you can go ahead and register on this link. Now, there is an opportunity to become UiPath Student Developer Champion. So who can apply for this? The students from the college that don't have an STC, like active, who doesn't have an active champion, they can go ahead and apply. The new STCs will serve 1 year term. And also, new champions will be onboarded every 4 months. This year, STC program application is open throughout the year. So please make use of this wonderful opportunity and you can apply it here. This is the link for it. Okay, before we end this session, do you guys have any questions for Palani? You can shoot in the chat box. Any questions, guys?
To add it what Vidya said, if you have any questions, maybe if you're finding with interest of time, maybe you can reach out to UiPath Forum,
Yeah.
or you can also reach out to me through LinkedIn, and you can. I'm always there to discuss on anything, any topics that you have. And we have some lineup of sessions coming up in the next week and same week where we are now. And I also try to cover up your questions with that, so that if you feel free to drop your questions in the chat so that I can try to answer them in the next session as well, if we're running out of time.
They're asking for your LinkedIn ID.
Oh yeah, okay. I will share my screen, maybe. Or I'll paste this image. You can, or one second, let me put the link. Okay. Mm, okay, here we go.
Palini, you want to take the question now, or I'll suggest them to go on and use the forum and your
Yeah,
LinkedIn.
I would recommend to go with the
Okay.
forum, but you can reach me anytime with the forum or with the LinkedIn.
Okay.
So I have pasted my LinkedIn profile in the chat so that you can just click a hit and then follow me up there, and you can ping me for any discussions.
Yeah. Pawan, please reach Palini out on these links. Okay. Somebody said the link is not working. Let me just repaste the link.
Okay, I have pasted. Can you please try once?
Yeah.
Yeah. In the meantime, let me start. I mean, terms, practical things. Perfect. So to answer Pawan, we have a session on the implementation part where we'll be looking at agent builder and the other components or the other tools that you can use to build an agent. But it's equally important to understand the core concepts so that you know where to use an agent and where not to use, or maybe how to use an agent in a better way. So it's very important to understand these fundamentals, because everyone has an idea and everyone come up with an idea, but unless you don't have a clear idea of how to bring up those ideas at real time, then you must be having a fair understanding of these fundamentals, and that's where we are focusing on it now. So I do see many questions, but I'll just keep a note of these. I think we are running over time of 6 minutes. So considering the interest of time, I will come up with the answer for these questions. So stay tuned for the next session.
Thank you, Palani. And the link is working fine. Just try again. It should be fine. So we will all meet you in the next session. Thank you so much. Have a great night ahead. Bye.
Thank you all.